Good morning. Good morning. Hello. I hope you all are doing well. On a 2-hour delay Thursday. Another curveball. Love it. All right. I was really hoping to not have to introduce this material to you this way, but I'm kind of running out of days here, so we need to make some progress. Hopefully you did the Shape of Life video and the questions associated with that, making progress on your vocab. Today we're going to go over some of the introductory material with phylum Mollusca with your notes. So if I can have your attention for just a smidge, that would be greatly appreciated. Let me see if I can get this done correctly. It's been a hot minute since I've done this, but hopefully now you can see we are doing our notes over the phylum Mollusca. Okay. Phylum Mollusca. This is the second largest animal phyla. We've got a whole bunch of different species of mollusca, second only to arthropoda, which we're going to be hitting up next. Moving forward. So this number says 90,000, but the numbers I'm getting, that's an old number. So we have tens of thousands of more that are fossil species, 70,000 extinct species. That's pretty much correct. But, you know, always discovering more and new things. So we'll see where that number ends up. Phylum Mollusca means soft bodies, and they're really soft and squishy. Some of them are protected by a shell, which we'll talk about later, but that specialized exoskeleton is not in all of them. But all of their bodies are soft and squishy. They have a very diverse This is a very diverse group, lots of differences in body shapes, styles, sizes, habitats, although they are all invertebrates. Okay, some examples that you're very familiar with would be snails and slugs. Okay, some that are more complex and more interesting, the octopuses, squid, cuttlefish. This one down here in the bottom left is the sea butterfly. It's so cool. It's so cool. I love to watch them swim or fly or whatever you want to call it as they move through the water. Whoopsie. Yes, there we go. Speaking of water, mollusks are mostly found in marine habitats, although there are some freshwater species. They tend to be terrestrial when they have high humidity. They still don't have great excretory systems. They need that water to help them purge the wastes. Something else that these animals need is a source of calcium, which we'll talk about later. Mollusks are triploblastic. They do have those 3 layers, the endo, meso, and ectoderms that we had talked about previously. They are true coelomates. They do have that true cavity, and they are protostomes. During that gastrulation, if you remember way back when we talked about the formation, we did the morula to the blastula to the gastrula in that invagination where it would fold up. That first hole that becomes the mouth of the digestive system are the protostomes. So we've got a mouth first animal here. The coelom, or that cavity of the mollusks, are generally smaller. They're generally smaller, and we'll talk about that more later. But you can see there's this smaller coelom just around some of these organs. This area is not considered the coelom. Oh my goodness, sorry. It's only 2 o'clock in the morning, so be nice. Classification, we've got 7 different classes. We're gonna focus on 3, talk about 4, but focus mostly on 3. The one that I'm just gonna briefly mention and then move on is the polyplacophora. These are commonly called chitons. They have many different plates, many, placo plates, mini plates, and they just kind of hang out and grub on the algae along the shorelines. Gastropoda, this is one that is the largest class of phylum mollusks. They have the snails and the slugs and the nudibranchs, which are, they kind of look like slugs to me, but they're super cool, very colorful. We also have bivalvia, which bi means two, not a bicycle, but bivalvia, two valves, double shelled, double shelled. We got clams, mussels, and oysters. And then the third class that we're really going to focus on is cephalopoda, squid, octopuses, nautilus, cuttlefish. A couple more, and you can monoplacophora, aplacophora, and then the Scapholopoda. You can use your root words to break down what those animals are going to look like. Body structure. Okay, we've got huge variation in our body structure. One thing that they do all have in common is that they all have bilateral symmetry, and many have shells, which we call valves. They do have a three-part body plan. They're going to have, all of them are going to have a head, all of them are going to have a foot, and all of them are going to have a visceral mass. The head contains the mouth, right? And if we have sensory organs, the mouth, we're going to have a specialized radula, which we'll talk more about in a little bit. If we have complex developed eyes, or if we have simple eyes or photoreceptors, this is all going to be found in the head. When we get to the cephalopods or the octopuses, those are going to have much more complex eyes. The radula that I mentioned earlier is like this tongue kind of type organ. It has hard parts, and they kind of use it as a scraping mechanism. So the radula is used to gather food. Okay, it scrapes away as it's munching on things. The foot is the muscular organ, and as per the name, you can assume that this is going to be used for locomotion. Okay, the foot, when we have tentacles, these are modified feet or modified foot. The visceral mass, that third part, is where the organs are going to be. Okay, super important part of phylum Mollusca is the mantle. Around the visceral mass, there's this membrane called the mantle. Okay, and it's going to become super important if this organism does have a shell. This is going to be secreted from the mantle. Along with the mantle, we have the mantle cavity, and it's that space just outside the mantle. This is where the exchange of materials will happen, right? So when we're talking about respiratory organs, whether it be lungs or gills, that gas exchange is going to occur in the mantle cavity. It's also where we're going to exchange digestive or excretory materials. We have reproductive materials. It's going to go through the mantle cavity. Specialized mantle cavities in our cephalopods, like the squids and the octopuses, they're going to be able to use this mantle cavity for jet propulsion, which is how they are able to move so quickly. Mentioned the shell earlier. It does come, the material for the shell is secreted from the mantle. The shell is formed right in the beginning of the life of the organism at an embryonic stage, and it will continue to grow throughout the life as the organism continues to grow and develop. We can see actually the rings of development. You can tell the age approximately using these rings, just like a tree. The shell is composed of 3 separate layers. That outermost layer is the periostracum. Okay, that's the outermost part. It's going to kind of lay out a matrix for the binding of the calcium carbonate, which is the middle part. Okay, the calcium comes from the environment. The organism takes it up and uses it to create a matrix. As you can imagine, calcium, just like the parts of our bones, it's a hard structure. You know, seashells are very hard. That's the calcium coming in to provide that strength. And then the innermost layer is called the nacre. This is the mother of pearl, is what it's also called. And this is that material that will create pearls as their irritant comes into the bivalvia. We'll talk about that more again later. I think that might be it. Oh, here we go. This is the last one. Last slide for now. When we have these soft-bodied organisms, they do have an internal shell, for the most part. The octopuses are pretty much the only ones that don't have any shell at all, but it can be a modified shell and it can also be internal. So the one I think is most interesting is the cuttlefish, this one here, or the cuttle bone, this right here. If you've ever had a pet bird or have seen this white thing hanging out in the bird cage, for somebody has a bird as a pet, this cuttle bone is something that is harvested from the cuttlefish, and it's a source of calcium for that bird. They like to sharpen their beaks and consume that cuttle bone. I didn't realize that it actually come from the cuttlefish until recently. But anyway, that's it for that. I will stop sharing there. Hopefully that worked out well. Keep it nice and short and simple. Again, hopefully I'll be back on Friday. If not, hang in there. I'm sorry. This sucks. That's all I have to say. Hope your first week is going fairly well. All right. Reach out if you need anything or if I can help with anything, and hope to see you guys soon. No, goodbye.